All right, so I'm going to try to give a few lectures on trigonometric geometry. Okay, so first lesson should be the definitions of all those trigonometric functions. Okay, we begin with a triangle. Okay, okay, we begin with a triangle. First of all, we have the right triangle, right? The right triangle, and then you have three sides. This is B, that's A, and C. So we know the Pythagorean series, x squared plus b squared equals c squared. Okay, so everybody know that. Then inside this triangle, which we should know is we have three angles. This is alpha, that's a beta, that's a 90 degree. Okay, so now we know that alpha plus beta plus 90 degrees is 180 degrees, so this should be called a 90 degree. Okay, so those are the basic things about right triangle. Then, then we introduce the following notions of trigonometric functions. One is called sine alpha. Sine alpha is going to be uh, B over C, the ratio. Now, this ratio will be independent of the size of the triangle because if we enlarge the triangle proportionally, keeping the angle alpha unchanged, this ratio will be unchanged. So that's why it's we call in mathematics, we call it well-defined because another big triangle, even larger, as long as this angle is not the same. And here is A prime, B prime, C prime. And then this is B prime over C prime. It's the same, okay? Because they're similar triangle, by similarity triangle. All right, so cosine alpha will be A over C, okay? Which even for another triangle, this will be C, A prime, B, C prime, okay? This ratio, you can show that it's the same. Now, after you introduce these notations for sine alpha, cosine alpha, so what we can get from there? Okay, let's go back to you can discover lots of things. So you can also have a sine. Yeah, you can also write down sine beta. Sine beta, you have to turn around, right? It should be B over C. You see? And sine cosine beta, you will see cosine will be sine beta. Sine beta is A over C. Yeah, A over C. Okay, cosine beta will be B over C. Okay, that's interesting. All right. So as you can see that we can get lots of identity here. Sine beta is A over C, but A over C is cosine alpha, right? Yeah. And then this B over C will be sine alpha. So immediately you can derive a lot of identities by yourself. Okay. You can also write in the following way, alpha, beta is going to be 90 degree minus alpha. So sine 90 degree minus alpha. Okay. Because beta. And this will be cosine. Yeah. This will be cosine beta. Beta is 90 degree minus alpha. So what do you got? You see, you give a definition, then you derive lots of identities. So let's write down two formulas. Okay, so cosine alpha equals sine 90 degree minus alpha. And the sine alpha equals cosine 90 degree minus alpha. Okay, you see? And you can get more identities. Okay, we already use this definition plus this identity, right? We got these two important formula. Okay, now as a mathematician, right, supposed to be, then what you can get? We look at the first Pythagorean theory. Remember, right? A squared plus B squared equals C squared. Let's go back to this triangle. Okay, so this is B, this is A, this is C. Okay, that's alpha. What you can do, modify. Okay, this is Pythagorean theory, right? You divide both sides by c. How about that? C squared. What do you get? A over c squared plus b over c squared equals what, right? Yeah. Then, because you already defined a over c is cosine alpha, b over c sine alpha. So you get another important identity. So R sine alpha, sine beta, essentially, they're not the independent functions. Okay? They are related. If you want to find the, if you know sine alpha, you can get, right? You move that. And if you want, if you get cosine alpha, you can get sine alpha. Okay? Okay, so we can have the following question. If alpha is between 0 and 90 degree, and if I know cosine alpha equals 3 over 5, right? So question is, what is sine alpha, right? Then you can get, okay, you can get sine alpha equals 1 minus cosine squared. So that's another formula you find out. It's 1 minus 3 over 5 squared. And after you simplify, it's a 4 over 5. Okay, got it? Good. Uh, yeah. So we continue to write more formulas. Okay. Now you can also find, yeah, you can also find, if I ask you what is sine alpha, sine 90 degree minus alpha, if I wanted to find out. And then you have to use another formula because sine 90 degree minus alpha is going to cosine alpha. Okay. Since you already know cosine alpha, it's 3 over 5. Okay. Good. So what else we can do? Oh, yeah. Okay. So we continue. Okay. Now look at this triangle. Let's go this way. Okay. This arbitrary triangle, not the right triangle. Okay. So I can say this is A, that's B, that's C. I can use this B, okay? And that's a C. Okay. This is height. Okay. This is angle alpha. Okay. So the area, remember, the area is going to be half of H times B. Do you agree? Right? Yeah. But on the other hand, sine alpha is going to be H over A. Do you agree? Okay. So what is H? H is A sine alpha, right? Okay. So if I plug into here, this will be A, B sine alpha. So if you know the sine value of angle, if you know those two sides, you can get the area. All right. So here's a question. I have a triangle. All right. I have a triangle. If this is alpha, if it's this two, here is 5, right? If cosine, if, yeah. So if alpha is between 0 and 90 degree, okay, small angle, okay? And if I know cosine alpha equals, I still say equals 2 over 5, something like that. Doesn't matter, okay? Find the area. Okay. So first of all, you write down the formula. Okay, so area is gonna be half of A times B sine alpha. Okay, but you don't know the sine alpha. So you have to find out the formula, right? So that means here A is going to be 2, B is 5. And sine alpha should be equal to square root of 1 minus cosine square alpha, right? Okay, so it's going to be 1 minus 2 over 5 square. And then you simplify it. And then you get 21 over 4, 21 over 5. All right, so that is uh yeah, that is a sine value. So therefore the area is gonna be half of 2, 5, square 20. Okay. So you simplify, 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 it's just square 25, 21. All right. So you get square 21. So that is the area. Let's go back to this. Just look at it. I don't know the exact value of this, right? Okay. Uh, question. Okay. Question. What is sine 30 degree? Okay. So we're trying to find out. So here's what we do. This is 30 degree. Okay. This is a 60. This will be 60 degree, right? This is 90 degree. Okay. Right. So we try to find out sine 30 degree. We also want to find out cosine 30 degree. Okay. We want to find out sine 60 degree. We want to find the cosine 60 degree. Okay. We find all those special angles. Look at this triangle. I can do the following. I duplicate. Uh, Let me check. So after you introduce, okay, so this will be 60 degree. You duplicate, this will be 60 degree, right? This, what is this angle? 60. So what do you get? You get the angle, triangle. What is called this triangle? Equilateral. Okay, equilateral. So they're all equal, right? So let's assume this side is 1. This side is 1. This side will be 1, right? So what do you got? We go back to here. This is 1. This is the height. So this is h. This will be 1/2. Right? Okay, so what is h? H by the Pythagorean theory is 1 square minus 1/2 square. So it's going to be that. All right, so now I can get sine 30 degree 1/2. All right? And cosine 30 degree square root 3 over 2, because this over that. And cosine, sorry, sine 60 degree, I can use the formula, I can use a picture here, okay? Because sine 60 will be cosine 30 degree. It will be square root 3 over 2. All right? And then cosine 60 degree will be sine 30 degree is going to be 1/2. Okay, so you got all the special. Okay, now how about 45 degree? Okay, how to find it? Okay, let's find out 45 degree and cosine 45 degree. Okay, uh, how to make a 45 degree? Oh yeah, here's a square. You divide this. Okay, okay, okay. So this is a 45 degree, 45 degree, right? So this side is 1, this side 1. What is the other side? Square root 2. All right, so now sine 45 degree is going to be 1 over square root 2. If you rationalize the denominator, you get this. Okay, so cosine 45 degree is also 1 over square root 2. And that is a square root 2 over 2. So we find out all the special angle, the sine value, cosine value, right? Right? Yeah. So this is about what else we should be able to find out. That's all about the triangles. Okay, so later, okay, later mathematicians, this is beta, okay? So here's the alpha plus beta equals 90 degree. So later, here's B, here's A, here's C. So later we introduce other two angles. We call tangent alpha. Tangent alpha is going to be B over A, this over that. And then if you divide the B over A, then divide by C and over C, right? And then what do you get? This is sine alpha, this is cosine alpha. So nothing new here. Essentially, there's only one trigonometric functions, almost, because sine and cosine are related, right? And then cotangent alpha is just A over B, just turned upside down. So this A over C, B over C, it's cosine alpha, sine alpha. Okay? And then the others we call the secant alpha. Secant alpha is going to be is going to be a c over a upside down c over a c sorry c over a, yeah, it's one of a cosine alpha. Okay, that's a little confused. Cosecant alpha, that just c over b. It's one of sine alpha. Okay, it's those are just not new functions. Just they just give them more. Okay, now I just want to only mention one formula, so you can derive more for relationships. Okay, let's look at tangent alpha. Okay, remember, uh, cosine square alpha plus sine square alpha equals 1, right? So let's divide both sides by cosine alpha. How about this? Cosine square alpha. Then what do you get? This is 1, right? And sine alpha cosine alpha is tangent square alpha, right? And this 1 over cosine alpha will be secant. That's another identity sometimes used. So you have lots of identities. If you forgot it, you derive it by yourself. In my opinion, you just memorize these basic ones. If you're not sure, you just derive it quickly. Okay, because your brain is limited in memory. Okay, so far, what are the important formulas? You give the definition of sine cosine, right? And you have this identity, right? And then you have the relationship between sine alpha and cosine alpha. So those are the basic uh, trigonometric functions and the special values. Okay, and its applications to find the area, right? Find the area, right? Yeah, and yeah. Now the question is, what happens when the angle is larger than 90 degree, right? How to define it? Okay, so we have to extend the notion. So how about, yeah, for large angles or negative angles? How to measure it? So think about, right? For small angles, we can measure it. Okay, how to do that? Well, we just measure it, right? But how about this, right? It's still possible if we draw the triangle, then this is still part of the triangles, right? And how about this? Then you have two options. Either measured here, right? It's greater than 100 degree, or this one, who knows, right? You only choose a smaller one, then the angle is always between 0 and 180 degree. But in this case, if you measure, so we have to find a way to measure the angle. So here's the definition, okay? So this is the initial side, called initial side. And then we have to tell, when we talk about angle, we have to say which is the initial side, what is the terminal side. Terminal side, okay? And then you rotate the initial side counterclockwise. Okay? And the size of this angle will be called angle of the between these two. Doesn't matter this will be horizontal or not. It could be something like that initial. And this will be terminal. And then you rotate this. So this will be this decide how big of this angle. So doing like that, the angle is between 0 and 360 degrees. Because if this is the initial, this is a terminal, then this will be the angle, not the other one. Okay, so this angle is between 90 degree and 180 degree. In this case, yeah, it's the same. Okay, but this one, the angle theta is greater than 270 degree, less than 360 degree, for example. Okay, so my question is how to extend the definition, extend the definition for of sine alpha, cosine alpha, and so on, right? When alpha is greater than 90 degree, if it's not a part of the triangle, in the right triangle, right? Think about how to do that. Uh-huh. Being creative? No idea? All right, so here's the way we do. Okay. First, I put this triangle into the XY plane. Okay. So this side is still B, this side is this A, this side is C. Okay. So what is coordinates of this point?
A, B.
Yeah, A and B. Okay. So this is the angle theta. So sine alpha equals B over C. Cosine alpha equals A over C. Okay. And the C is going to be square root of A squared plus B squared, the distance between those two, right? If you use this picture, you notice that A and B can be negative. So if I have the point here, this is the angle theta. And if coordinates A and B, and the C is the square root of A squared plus B squared, I notice that I can define sine alpha, sine theta to be B over C, right?
Negative A.
Yeah, cosine theta will be A over C. In this case, B is still positive, so still positive, this will be negative. But the sum of them still, because C is going to be the distance between those two. So now you can define any angle. So sine, got it? Right? Small change. You can define anything. So even this angle is here, and this is theta. You take arbitrary point here, and you look at the coordinates A and B, right? Right? And then the distance is C, right? Then you still can say sine alpha, sine theta is going to be B over C, cosine theta equals A over C. Now, what is the value of sine theta in this case? What is the sign? Positive, negative? Yeah, negative in this case. And this is going to be positive because A is positive, right? Okay, so you have four quadrants. For sine theta, which quadrant is positive? Okay, for sine theta. In which quadrant sine theta is positive? Yeah, so positive, positive, negative, negative. For cosine theta, yeah, that's a positive, negative, negative, positive. Okay, so let's find out what is the value of, oh, anyway, I just want to say we still have the following identity. Sine cosine square r theta plus sine square theta equals 1 for any theta. Right? Do you agree, right? Why? Because it will be a square plus b square equals c square. Doesn't matter a is b or negative positive. Okay, so here's the question. What is sine 330 degree and cosine 150 degree? Okay, let's find out. So let's do 330 degrees. So where's 330 degree? 330 degrees is 330 degrees is 360 degree minus 30 degree, right? So that means it's here. So this will be 30 degree, right? But you measure it in the following way, 330 degrees, right? Yeah. And so how to find sine 330 degree? You need a point. You need the coordinates of this point. Okay? Now, what you can do is you just look at the special triangle here. 30 degree. This side is 1, this side is 2, this side is square root of 3. About like that, right? So, what is coordinates of here? I think the first coordinate compared with that triangle. A is positive, right? What is the value of A? Huh? Square of 3. What is the coordinate B?
Negative.
Yeah, -1. Okay. So what is a C? C is gonna be is C is gonna be 2, right? Yeah, C is 2. Okay. Square root of A square plus B square, so it's 2. Okay, now you can have sine 330 degree is going to be B over C. So which is -1/2. Okay, that's it. Now 150 degree. Where's 150 degree? 150 degrees is the same here. It's 150 is going to be 180 degree minus 30 degree. So this will be 30 degree. And here 150 degree. Okay, it's a similar. You choose a point. I think in this case, B is A is -3. B is 1. Okay, C is going to be still 2. So cosine 150 degree is going to be A over C. This side over that. So A over C, square root of 3 over 2. Okay, so that's how do you get 怎么会是整天睡觉? So that is how do we find out, right? Okay, so I wanted to find out what is the value of cosine 240 degrees. Please do it. Okay, I'll give you 1 minute. Think about. We're talking about cosine. You have to use coordinates. You have to mark this one negative. Yeah. Okay. So, so here's the angle, right? So that will be 240 degree, which is 180 degree plus 60 degree. Okay. So you take a point and the coordinates of this point, I think the first coordinate will be -1. The second point is negative square root 3. They both are negative. Yeah. So C is a 2. Okay. So therefore, cosine 240 degree is B over C, which is B over C or A over C? No, A over C. Okay, A over C. So which is -1 over 2. Okay. Yeah. So yeah, be careful. Yeah. Yeah. So this, how do we calculate the sine? Okay. And then use a sine, cosine, you can get tangent, cotangent, secant, and that's all about the trigonometric geometry. Now let's try to figure out the graph. Okay. How about the graph? Let's figure it out. The graph of y equals sine x. Okay. Uh, Maybe we use an angle. It's a bit easy to, yeah, let's use the angle. Okay. So this side, yeah, this side is angle theta, this side is a y value, or you can use any values. Okay. Now, inside here, we have to look at circle imagine. Okay. This is a theta. Okay. When theta increase, and this C is going to be what? And here's A and B. Okay. So if C is 1, then sine theta is going to be what? It's going to be B, right? Because B over C, that's just B value. Okay? Just B value. So in other words, I can use B, it's better. It's a B. Okay? Okay? So if here's a pi over 2, here's a pi, here's 3 pi over 2, I'm going to increase. Here's 2 pi. Okay. Oh, pi over 2 is 90 degree, 90 degree, 100 degree, 270 degrees, 360 degree. Okay, it's degree made. Okay, so let's increase when theta is 0, B is 0, right? Right? When theta increases to pi over 2, B is going to be 1, right? So it's increasing. B is increasing when theta increases. This is theta. That's a B. So when theta reach to pi, B gets 0 again. When theta greater than 180 degrees, it's going to negative. Okay? And then when theta get to 360 degrees, that you get 1 again. So you're repeating. So this will be the graph of sine. Okay? sine theta. And then traditionally, we always use a y equals sine x. Okay? Traditionally, yeah, we use x value and sine value. Okay? So, so this will be periodic function. Okay, and here will be pi, 2 pi, 4 pi. Yeah, 3 pi. Okay, it's periodical. Got it? Yeah, this is a graph of sine x. So sometimes negative, sometimes positive. Okay, sometimes negative, sometimes positive. And all right, so 30 minutes we cover most of them. Okay, so then there are lots of identities. I don't have the example here, so you have to verify. Okay, just like what we did, verify. Uh, yeah, I don't have an example. We can do this verify identities. Okay, because sine, cosine, tangent, cotangent, they are not all independent functions. They're dependent. So sometimes you can change if one to another one. Okay, easily. Okay. So for example, yeah, let's look at this, how much we can change. Okay. So 1 plus sine theta over 1 minus sine theta. Okay, if you get that, right? Let's modify. You see, you can change a lot, actually. Okay. So when you see something like that, okay, you can also do this. You multiply the denominator by 1 plus sine theta. Then this one by sine theta. Okay, right? And then the denominator will be 1 minus sine square theta. The numerator is 1 plus 2 sine theta and sine square theta. Okay, and then you will see this will be cosine square theta, 1 plus 2 sine theta plus sine square theta. And then you continue. 1 over cosine theta will be secant square theta. And this will be 2, you know, yeah, tangent theta, secant theta. And this will be secant, tangent theta. Okay? This will be tangent square theta. So sometimes they ask you to simplify this expression. There are lots of the same expression shows up in many different way. Okay? And then you will see that this will be secant theta plus tangent theta square. Okay? So there are many expressions. There are many expressions. So sometimes they have please verify this identity equal that. Then you have to change because that your target expression involves sine theta only. So you have to change secant theta to sine theta, cosine theta, tangent theta to sine theta or cosine theta. Okay. Now, our next, the very last one, I want to remember this is special right triangle, right? Special right is a Pythagorean theory, right? So this is a theta. Here's B, this is a A, that's a C. I know C squared equals A squared plus B squared. Okay. So what happens if this angle is not 90 degree? What happens if this angle is like that? If this is alpha, okay? And this still theta, okay? It doesn't matter. So how this ABC are related? Okay? How these things related? Okay? How these things related? So I just like a research project, right? I know that if alpha is fixed, A, B are fixed, C depends on alpha, right? Here, C squared equals A squared plus B squared, right? Now the question is, how does C depend on A, B, and alpha? Right? Definitely, right? C depends on A, B, and alpha. So when you work on some math problem, suppose like 300 years ago, you're Newton, right? And you and you then you have to you face this problem. You know the Pythagorean theory, right? Right? How do you do that? Suppose alpha is bigger than you can there are two cases here. Case one, case two, alpha is larger than 90 degree or less than 90 degree, right? So that's two possibility. One is looks like that. This is alpha less than 90 degree. Here's A, here's B, this is C. Another picture I just show you this alpha greater than 90 degree. This is a B, this is A, this is C. In either case, this is a research project, right? Some genius kids can figure it out. Okay, you know, being a scientist, you have to constantly ask the questions. It's not like, oh, I'm satisfied with the sample series, that's great, blah blah blah, right? Then you look at this picture. Can I get? Sometimes you're given specific numbers, like yeah. Sometimes you're given this. You can solve it by yourself. Maybe this is 120 degree, and this side is a three. This side is four. What is C? Find the C. Okay. Maybe you get slowly get some ideas. Find the C. Okay. How to find the C? Let's find out first. Then maybe you get the idea to get a general formula. How to find the C if it is 120 degree, right? 120 degrees is special, 120 degree is 90 degree plus 30 degree. Is going to 180 degree minus 60 degree. Okay? So, so what's the idea? I'm waiting for you. Think about it. Yeah, you can solve it. Okay? Yeah, I'll give you a couple minutes. Oh, yeah.
I feel like it's an easier way to do this for me.
You figured out? Square root 30. Oh, yeah, that's a good idea. So here's the point, okay? You draw the line at H, you find the height. Okay, if you find the height, you find this. This side I call let's call it X, okay? This side called Y. Okay? If you find X and Y, then you get Pythagorean theory to this right triangle. Okay? So how do you find Y? Because this side is 3, so this will be 60 degree, right? Okay? So that means sine 60 degree equals Y over 3. So Y equals 3 sine 60 degree. Sine 60 degree is square root of 3 over 2. Okay? Yeah. That's the first thing. So you get a Y. And the X, because cosine 60 degree is going to be X over 3. So X is 3 cosine 60 degree. It's a 3 over 1 over 2. Okay, so you get X and Y. So C is going to be C squared is going to be 4 plus X squared plus Y squared. So here 4 plus 3 over 2 squared. Y is 3 squared, 3 over 2 squared. Okay, so let's do it. And that will be, I think, 11, right? 11 over 2 squared. Let's open 121, 4. And 9 times 3 is 27, right? So I got 148 divided by 4, right? Then you simplified 74 divided by, is divisible by 4 or not? Right? So what is that? 148 4 is 37. Okay? So C is a square of 37. All right. Yeah. Once you solve this problem, you pretty get a good ideas, right? So why not we derive the formula in general? We can assume, yeah, what is my original one? Yeah, my original one here is the B and the A, okay? So use the A, that's a B, that's a C, okay? So this is alpha. So what I'm gonna do, I find the H and find the Y, find the X, okay? So this will be careful. This will be 180 degree minus alpha, right? Okay. So what does that mean? So uh I get X. So Y equals B sine 180 degree minus alpha. And X is B cosine 180 degree minus alpha. Okay. So the formula would be C squared equals A plus B cosine 180 degree minus alpha square plus B sine 180 degree minus alpha. Okay, so I multiply this out. It'll be A squared plus 2AB cosine 180 degree minus alpha. Okay? And plus b square cosine square 180 degree minus alpha plus b square sine. And you see that this is just equal to b squared. Do you agree? Because sine square plus cosine square equals 1. So you get the very nice formula, a squared plus b squared plus 2ab cosine 180 degree minus alpha. Okay? Yeah, that's a c squared. Now, that is in case alpha is greater than if alpha is greater than 90 degree. Now, if alpha is less than 90 degree, maybe it's slightly different. Okay, so for example, oops, go back. Okay, oh, pen space is low. Okay, okay. So let's see. There's a case. If this is a yeah, A, B, and C. Okay, so this is alpha. So here, if alpha is less than 90 degree, how about this, right? So the picture is slightly different. This will be Y, that will be X. Okay, right? So that would be X. And I think similarly, Y equals B sine alpha, right? X will be B cosine alpha. Do you agree, right? Yeah. So now you can get C squared equals, use this right triangle,
看不见爹，只能这样看啊。
A minus X squared plus Y squared. Do you agree? Apply Pythagorean theory.
对吗？坐起来。
Okay, so now you get uh, A minus B cosine alpha squared, B sine alpha squared. So let's derive the formula. It's A squared minus 2AB cosine alpha, B squared cosine square alpha, B squared sine alpha. So this will be B squared again, right? So we get A squared plus B squared minus 2AB cosine alpha. So this looks it's similar, but much better. It depends on the angle. Okay? So that is in case when alpha is between these two. But let me summarize what we got here. If this angle is in this form, and c squared equals a squared plus b squared minus 2ab cosine alpha. If this alpha is here, this will be c squared equals a squared plus b squared plus 2ab cosine 180 degree minus alpha. Now, it turns out to be these two can combine into one form. Okay, so what's the relationship between this and that? If alpha is greater than 90 degree, okay? Okay, so let's see. That's an interesting problem here. If this is alpha, okay? Uh, if this is alpha, okay? So if alpha is between 90 degree and 180 degree, okay? So what happens? This is C, that's A and B, right? And this will be 180 degree, right? Minus alpha. So I'm going to draw another picture here. Okay. So this will be 180 degree minus alpha. Okay. Right? It's the same. So if I use if I use A and B, then if I use A and B here, and this will be the only difference is A is negative here, right? Right? Got it? Okay. So as you can see there, cosine 100, uh, cosine alpha. Sorry, where's my pen? Okay, I just use a red pen. Okay. So cosine in this picture, cosine 180 degree minus alpha is going to be A over C. Okay, because this end. Okay. Cosine alpha is going to be negative A over C. Okay. So that's a relationship. Got it? Right? Look at. So that means this one can be replaced by negative cosine alpha. So that means doesn't matter, the formula looks same regardless if the alpha is between 0 and 90 degree or 90 degree and 100 degree. Okay, so we have the following identity: cosine 180 degree minus alpha equals negative cosine alpha. Always. We not only we discover this identity. One is negative, the other one is positive. Doesn't matter which alpha here. So finally, we got c squared equals a squared plus b squared minus 2ab cosine alpha, regardless for any alpha between 0 and 180 degrees for any triangle. And here's A and B. That's a C. Okay? This is called the law of cosine. Okay? So we use that to compute any angles. And here's the example: given triangle. Okay, if this side is 2, this side is 3, this side is 130 degree, so maybe it's better angle, right? Find the C, so C squared equals a squared plus b squared minus 2ab cosine theta, right? So use this formula. So it'll be 2 squared, 3 squared minus 2 times 2 times 2 times 3 cosine 130 degree. And you can use a calculator to estimate. Okay. So let me try use a calculator to see, because this is this will be the special triangle, right? So here 2 square plus 3 square minus 2 times 2 times 3 times 130 degrees cosine. Okay, so that would be 17.40749597. So C will be estimated will be about 4.172229136. All right, so you have to estimate if the angle is not special. Okay, if the angle is not is a yeah, if the angle is, and that makes sense, if you look at the picture, okay, and sounds like that because the largest possible value for C is 5, so this is less than 5. But yeah, about triangle, you see, triangle, three numbers form a triangle, right? Here's A, B, C. So they must satisfy the triangle inequality. Otherwise, those cannot be the length of the sides. Triangle inequalities. Okay? So A plus B should be equal than C. B plus C should be greater than A. C plus A should be greater than B. Okay? So that's why when you get to the number, okay, when you get a number, this is a 2, this is 3, that's a C. Clearly, what is the largest possible value for C? Is the sum of these two numbers. So if we get some number which is larger than 5, something's wrong. You have to go back to check your formula. All right. And for the C, the smallest value for the C is going to be what? 1. Okay. You know why? Because one of the inequality gives you this C is greater than 1. And the extreme case is as follows. Okay. Extreme case is like that. Uh, what is the extreme case? Oh, the extreme case is as follows. That's a 3. That's a 2. So that's a C. Okay. So C cannot be shorter than 1. So when you get answers, use a common sense and check whether this is makes sense. Okay. All right. So what do we learn? Right? We learned the notation for an arbitrary larger triangle, arbitrary angles. And we define sine and cosine for angles smaller than 90 degrees using triangles. Then we use coordinates of the terminal side. We extend the definition to an arbitrary angles. And we got many identities. And we also derived the formula for the law of cosine. We also derived the formula for the area of the triangles. Okay, so that is what we learned. Okay, and especially let's go back to the formula which related to MC10. So if you have a triangle, if you know this is A, this is B, if this is alpha, and the area is going to be half of AB sine alpha, right? So if you have two triangles, this is alpha, here's A and B, another triangle may be even longer. Okay, this is A prime, B prime, this is alpha. So let's say this is A, B, C, A prime, B prime, C prime. Then we see what is the ratio of the area if they're a ratio of the area. Triangle ABC over the area of the triangle A prime, B prime, C prime. Okay, so first of all, by formula, this is going to be AB sine alpha, right? And that is A prime and B prime sine alpha because the same angle. So therefore, the cancel. So you get AB and A prime and B prime. So that's why when you have two triangles have the same angles and the ratio of the ratio, yeah, the ratio of their angle, you get, you get this. Okay, where this is used for a geometric problem, okay, for a geometric problem, uh, let's see, okay, so like this 3, 4, 5, if this angle bisect, okay, find this H, right? You know how to do this problem? Because this problem can be solved using the comparison of the area. Okay? Maybe, maybe not. So how do you do that? So you don't know this is the X. This is the Y, right? So what do you do? And the area here is A, B, C, D, okay? I'm comparing those two triangles. Area triangle ABD over the area of the triangle ADC, okay? So first of all, those two triangles have the same height. So the area will be basically will be the height times, basically just x over y. Okay? If you want to put in more details, it'd be half of 3 times x, half of 3 times y, because 3 is the height. So x over y. Okay? And yeah, then you can also use the same angle, right? You can use the same angle, right? So that is because they have the same angle. That will be 3 times h, 5 times h, right? So that is going to be 3 over 5. So now you have x over y equals 3 over 5. And what you have to find another identity. Okay, because that's a base, x plus y equals 4. All right, so therefore, you can find x and y. And how to do that? You can say let x to be 3t, y to be 5t. Okay, you put together x plus y equals 8t, which is 4. T is going to be 1/2. So therefore, x equals 3 over 2, y equals 5 over 2. Then you go back. Oh, yeah, since you already get an x. So this is a 3, this is h. X equals 3 over 2. Then you can get h. Okay, so h is going to be square root of 3 square plus 3 over 2 square. And then it's going to be 9. Here's 9 over 4. 3 over 2 square root of 5. Okay, so we solve this problem. All right.